So in this topic we will talk about relations. So we have known that if there are sets A and B and we take a Cartesian product, it is a it's a set of all ordered pairs possible such that first element belongs to set A and second element belongs to set B. So in a Cartesian product, what we have got, so we make some rules. So depending upon some rules, we pick some of the ordered pairs. So that becomes the relation. Okay. So following some rule, we pick only some of the ordered pairs in a set of all possible ordered pairs. In a set of all possible ordered pairs is a Cartesian product. So we have set A and B, two sets. So if from the Cartesian product what we have, so depending upon some rule, okay, so we'll see some examples. Okay, so because depending upon some rules, we make a subset of that Cartesian product. That subset is the relation. That rule is the relation. Okay, so we can list the all the ordered pairs depending upon that relation. So we'll just see the uh, definition here. Okay, so let A and B be two sets. So R is relation from A to B, then R is some set of ordered pairs A comma B where A first element belongs to A and second element belongs to B. So it is denoted by A comma B, that ordered pair belongs to some relation R. So we can also in words say A is related to B by R. So we can also write like this: A R B. So A is related to B. So this like this also we can write. These are the notations. So relation will be always, again as we discussed, relation will be a subset of Cartesian product between A and B. So we'll take an example. So let the set equal to 0 comma 1 comma 2 and b equal to 3 comma 4 comma 5. So we have defined some relation. Okay, so from the Cartesian product we have made a subset. So 1 comma 3, 2 comma 4 and 2 comma 5. How can we write this one? So 1 relates 3, 2 relates 4 and 2 relates 5. So we can also draw a relation diagram. So 0, 1, 2, this is from set A. Okay, so 3, 4, 5, this is from a set B. So 0, it does not relate to anyone. 1 to 3, so we have a directed line here, not an undirected one, directed line here. So 2 to 4 and 2 to 5. So we are already familiar with the relations and we are just brushing up what we have studied in our previous years. So next one, so next question in front of us. Suppose we have a set A, okay, so with m of elements, and set B with the n number of element. Okay, so how many relations are possible from A to B? How many relations are possible? So we'll discuss first and then see the points. Uh, we have already stated that A cross B, so our relation, all relation will be, if a relation is defined from A to B, then that relation will be a subset of A cross B. So that is all possible all possible ordered pairs, right? So the question now distills down like this: how many subsets are possible for A cross B? Those many relations are possible. So how many subsets are possible for A cross B? Those many relations are possible from A to B. Okay. So how many subsets are possible from A to B? So so this is known as there is one thing called power set. So what is power set? Power set is a set of all possible subsets. Set of all possible subsets. So power set of some set, a power set of a set given set is set of all possible subsets. Okay, so just we'll take an example and see what is a power set. Okay, so suppose we have uh, a equal to uh, 1 and 2. So just a simple example. Okay, so power set of a we can write like this: null 1 comma 2 1 2. So these are all the possible subsets for set A. Okay, so how many are there? 1 2 3 and 4. So how many power sets are there for a given number of sets? If the n number of elements are there for a given set, then 2 to the power of n power sets are subsets are possible. Okay, so if we have a set with n number of elements, then 2 to the power of n subsets are possible. Okay, so the number of elements in a power set is 2 to the power of n. So this is about a power set. Okay, so what is a relation? Okay, relation is a subset of Cartesian product between A and B. Okay, so how many relations are there? So how many subsets are possible for A cross B? Those many relations are there. So how many subsets are there? That question leads us to calculating. So what will be the power set of A cross B? Okay, so the number of elements in power set of A cross B is the number of relations possible. Okay, so how many are there? So we know that in A cross B, how many elements are there? How many elements will be there? So if there are m number of elements in A and n number of elements in B, then m into n number of elements will be there in A cross B. So we have seen in our previous video. So what is a power set? How to calculate a power set? So if we have n number of elements in a set, then 2 to the power of n number of elements will be in the power set. So if there are m cross n, m into n number of elements are there in A cross B, then 2 to the power of mn number of elements, number of power subsets are possible for A cross B. So if there are mn number of ordered pairs in A cross B, if there are mn number of elements in A cross B, then there are 2 to the power of mn subsets possible for A cross B. Okay, so we are taking what is the power set of A cross B. So let's see it. So if A is a set of elements with m elements and B is set with n elements, so find the number of relations from A to B. So that's our aim. So a relation from A to B is a subset of A cross B. Okay, so therefore number of possible relations from A to B is the number of possible subsets of A cross B. That is power set of A cross B. Okay, so number of possible subsets of A cross B is equivalent to asking the question, what is the number of elements in the power set of A cross B? So if A has m elements and B has n number of elements, then A cross B will be having mn number of elements. Now if A cross B has mn number of elements, then power set of A cross B will be having 2 to the power of mn number of subsets. So this is what about number of relations from possible from A to B with A with m elements and B with n number of elements. Okay, next question. Let A and B be finite sets with the number of elements in set B is 3. If there are total of 4096 number of relations possible from A to B, then what is the number of elements in A? Okay, so now we know that total number of relations possible is 2 to the power of mn. So we can write like this: to the power of number of elements in A and number of elements in B. Now so 4096 total number of relations is given to us. So we don't know what is the number of elements in A. We know what is number of elements in B. Okay, so 3 into number of elements in A, we will take it as M as a usual denote it is. So we apply log. So we need to find what is M. So we will apply log on both sides. Okay, so I will just swap this way because 3m is what we are interested in. So we will apply here log e to the power of 3m equal to log e 4096. Later, so we can write 3m log e 2 equal to log e 4096. So we can write it this way, m equal to log e 4096 divided by 3 log e2. Take it here. Okay, took it to denominator. So the answer what we get for this is 4. So m equal to 4. This is the answer we wanted. Okay, so we had 4096, we had 2 to the power of m. We now wanted to find what is the number of elements in A. We want to find what is m. So this is a 4096 equal to the power of 3m. We wanted to find what is m. We took log e on both sides and did the normal arithmetic, and answer what we got is 4. So this question is let A equal to 1 2 3, B equal to 2 3 5. Determine the following. First is the number of elements in the Cartesian product of A and B. So we'll just find that one. So number of elements in Cartesian product is if number of elements is in A is m and the number of elements in B is n, then mn is the number of elements which will be present in the Cartesian product of A and B. Don't get confused between number of relations from A to B and only the Cartesian number of elements in the Cartesian product between A to B. Okay, so the power set for the number of relations possible, we take the power set of this mn. Okay, number of relations, but here we are taking only how many elements are there in the Cartesian product of A and B. So m into n. So if you observe, A contains 1 2 3 3 elements, B contains 2 3 5 3 elements. So 3 multiplied 3 equal to 9. So this will be the answer for our first question. Next, number of relations from A to B. So number of relations possible from A to B. So it is number of relations possible from A to B is 2 to the power of mn. Okay, for more clarity. So 2 to the power of 9. So which is 512. So if it is a very big number, you can just write 2 to the power of something, but 2 to the power of 9 is calculable, and 512 it is. So next one is a number of binary relations on A. Binary relation on A means A to A, from A to A. So how many relations are there, possible relations are there from A to A? Instead of A to B, it is A to A. So we know here that A equal to 1 2 3 3 number of elements possible. Okay, so 2 to the power of number of elements in A, number of elements in again A, because the relation is from A to A. So 9. So incidentally it is same for both as in previous question. So the fourth one, so number of relations from A to B that contain ordered pair 1 comma 2 and ordered pair 1 comma 5. Okay, so we make note that there are 3 and 3 elements in A and B set. Okay, so let's assume that that there is no constraint. So when we did not have any constraint, it was 2 to the power of 9 power set possible. Okay, so now observe. So this 1 comma 2 and 1 comma 5 are set, they are to be there. Okay, so read the question, number of relations from A to B that contain 1 comma 2 and 1 comma 5. So it is declared that definitely these will be present. Okay, so there will be no permutations among having 1 comma 2 or not having this pair. Okay, 1 comma 2 and 1 comma 5 will be there out of 9 ordered pairs. Okay, so number of elements here is mn, that is 9, right? So we have calculated that. So out of 9, 1 comma 2 and 1 comma 5 will be there. So there is no choice about that. So what are remaining elements? 7. So if we are finding relation as 1 comma 2 and 1 comma 5 are already set and there is a condition that they have to be there, all the remaining permutation and all these things we have to make out of these as 7. This formation of subsets. Okay, this different subset we have to make out of these 7 remaining ordered pairs. Okay, so what is the question now boils down to like this. So what is the number of elements in the power of set of, what is the number of elements in the power set of so A cross B minus 1 comma 2 1 comma 5. We are not considering 1 comma 2 and 1 comma 5 because they are already there, it is set. Okay, so how many elements are there? 7 are there. So only out of that 7 ordered pairs we need to make all our power set combination. Okay, so we have to define the power set because 1 comma 2 and 1 comma 5 are set, they are present. Okay, so 2 to the power of 7 is 128. Okay, so let's make it simple. So if you read textbook and all, so they are little complicated, you don't have to go that much. A cross B, number of elements in A cross B is mn, it is 9. Okay, so now this 1 comma 2 and 1 comma 5 are already present, it is set that they are present. So that will be 9 minus 2, 7. So the number of relations from A to B, okay, so we have to find keeping in mind that these does not participate in our power set formation. So only the 7 remaining ordered pairs participate in the power set formation. So it is 2 to the power of 7, that is 128 is the answer. Next one, number of relations from A to B that contain exactly 5 ordered pairs. So number of relations from A to B that contain exactly 5 ordered pairs. Okay, so number of elements in A cross B Cartesian product is 9. So while forming the relation, that is subset of A cross B, every time you are taking compulsorily 5 ordered pairs. Okay, so every time you are forming a relation, so you should have 5 ordered pairs. That's why, how do you find that one? So out of 5, every time you choose 5. Out of 9, every time you choose 5 of them. So there are 126 such combinations possible. Out of 512, there are 126 relations in which there are 5 ordered pairs. Okay, so every time out of 9 ordered pairs, every time for a relation you have to pick 5 of them. That's the calculation of 9C5. So combinatorics, I think you know, right? So n factorial by n minus r factorial multiplied by r factorial. So that formula you apply and you will get 126 will be the answer. Last one, number of binary relations from uh, that contain at least 7 ordered pairs A to B. Okay, so number of relations on number of binary relations on A means relation from A to A. So the result does not make any difference because A and B both have 3 number of elements. So the number of binary relations on A, that means from A to A, that contains at least 7 pairs. So observe here, at least if you had suppose exactly 7 order pairs, then 9C7 over. Okay, here it contains at least 7. At least 7 means it contain maybe having 7, 8 or 9, because total ordered pair possible is 9. Okay, total number of elements maximum possible is 9 as we have calculated before. So at least 7 they have given, so it may be 7, it may be 8, so it may be 9. So how do we calculate? So combinations for 7 plus combination for 8 plus combination for 9. Okay, so how do we do it? So all the possibilities where we choose 7 out of 9 order pairs plus all the possibilities which will we choose 8 out of 9 order pairs, all the combinations or possibilities where we take 9 out of 9. Okay, so that comes to 46. Okay, so at least 7 means whenever it is 7, 8 plus 9, possibilities of 7 because it is at least 7. Okay, so maximum is 9 we have. So 7, 8, 9 exactly means 9C, that one 9C7, 9C8 like that. At least means starting as starting point from that number all till the maximum number, all the possibilities you have to add. Next question, if A equal to 1, 2, 3, 4, 6 and R be a relation on A defined by the ordered pair belongs to the relation if and only if A is a multiple of B. First element is a multiple of second element. Okay, so write down R as a set of ordered pairs. So how can we denote in a symbolic form? So relation consists of ordered pairs such that those ordered pairs elements belongs to set A and A is a multiple of B. Okay, so let's start listing our relations. Okay, so 1 is a multiple of 1, 2 is a multiple of 1, 2 is a multiple of 2, 3 is not a multiple of 2, right? So 3 is a multiple of 1. Okay, so 3 is not multiple of 2, 3 is a multiple of 3, 4 is a multiple of 1, 4 is a multiple of 2, 4 is not multiple of 3, 4 is a multiple of 4, 6 is a multiple of 1, 6 is a multiple of 2, 6 is multiple of 3, 6 is not multiple of 4, 5 or 6 is multiple of 6. Okay, so this is the relation. So the relation R on the set of all integers Z is defined recursively by, so the basic condition, the first element is 0, 0. For later integers, if some ordered pair, some elements belongs to R, then first element plus 1, second element plus 7 belongs to R. Find all the set of all ordered pairs. So Z is infinite, so we need to have some mathematical form to denote. Okay, so let's write R. The first element is 0, 0. So if integer is 1, then 7. Okay, 0, 0 is there. So if S and T are 0, 0, then 1 plus 7 is also there. Okay, so it starts with 0, 0 as given in the question. Okay, so if S and T are 0, 0, then S plus 1, that is 1, 0 plus 7, that is 7, also is present in the relation. Okay. Next one is 2, 14 is present. If 3, 28 is present, and so on. So Z is infinite, so we cannot exhaustively list everything. Okay, so but we can denote it mathematically. So we can say that m comma n, okay, so is a pair of integers, ordered pair of integers, such that if the first element if you multiply by 7, you get the second, n equal to 7m. Okay, so second element is multiplied by 7 of that first element, n equal to 7m. Okay, so if m is there, then make 7m, then you will get n. Okay, so this is the way we are denoting it. The second element will be the multiple of 7 of the first element. So this is how we denote the relations. So this is a brief introduction about relations and how they work. So we are familiar with the relations, but we are just brushed up whatever is important for our future discussion. So in the next video, we'll go with functions and do some problems and see some basics how it works and all. Okay, so this is about relations.